Hi guys, this is Miss Scott here. Thank you for watching this video on the 5.1 notes. We'll start out with a bad joke of the day. So, what does an aardvark like on its pizza? Well, if you don't know, another name for an aardvark is an anteater. So of course he likes anchovies. Okay, so we're going to start chapter 5 today. So if you need to pause the video, what you can do is go ahead and write down the essential question. What is the relationship between a mid-segment and the non-adjacent side? And in order to answer that question, you're going to need to know what the definition of a mid-segment is. So go ahead and write that down, and then we'll talk a little bit about it. So a mid-segment is just a segment whose endpoints are the midpoints of a triangle's sides. And we're going to actually make some mid-segments, so you'll see what that looks like in our first example. All right, so let's go ahead and get started here. The first thing we are going to do is actually draw the three mid-segments of a triangle. So you need to have a ruler to do this. So if you need to pause the video and go get a ruler, make sure you do that. So I actually measured these ahead of time. Now, to make a mid-segment, what you need to do is start by figuring out the length of the sides. So this side here, I measured ahead of time, was 6.2 centimeters. So if I divide that by 2, I know that at 3.1 centimeters is where the midpoint would be. So you need to make a point in the middle of that 6.2 centimeter long segment. All right, so we're going to do that same thing with the other two sides. So if you want to pause the video and give that a try yourself, I recommend it. But I'm going to move along here. So I already measured these ahead of time. I found that this segment was 6.9 centimeters long. So, and then I measured 3.45. And that's a little hard to measure, but just do your best with it. So each of these is going to be 3.45 centimeters long. And then that last side here, again, go ahead and measure it. Make sure your answer agrees with mine. I had 8.6 centimeters, so when I measured, I put my midpoint at 4.3 centimeters. So that would be the middle of 8.6. Okay, so those are our three midpoints. Now to create the mid-segments, what we do is we connect those points. So that would be one mid-segment, this would be the next, and this would be the third mid-segment of that triangle. It kind of makes a Triforce looking symbol here. So any gamer fans out there will know what I'm talking about. All right, so now what we're going to do is those three mid-segments that we created, we're going to measure each mid-segment in centimeters. So first of all, let's measure the length of this mid-segment. And if you do that accurately, you should find that this is 4.3 centimeters long. If you measure this one accurately, you should find that that one is 3.1 centimeters long. And lastly, if you measure this mid-segment, you should, as you can probably guess, find that that one is 3.45 centimeters. All right, so that leads us to a relationship, which is actually our first theorem here. So this is theorem 5.1. which is called the mid-segment theorem. And we're going to figure out what that mid-segment theorem is by answering that question right here. What relationship do you see between the side lengths and the mid-segments that they are parallel to? Well, you probably see that this 4.3 centimeters is the same length as these 4.3 centimeters. So it's half the length of the side that it's parallel to. So that is all that this theorem says. The mid-segments of a triangle are parallel to and half the length of their opposite side. So in the example of this entire length here is 8.6 centimeters, so this mid-segment here is half as long as that. And that's true for any mid-segment of a triangle. Okay, so we're going to use that idea to work through some examples. So in these examples, we are going to find the value of x if DE is a mid-segment. So all of these segments here are mid-segments. All right, so in our first example, what we can do is if we take that segment DE, which they tell us is 5, and we multiply that by 2, that will give us x. So in this case, x is going to equal 10. And the outer length should always be longer than the mid-segment. All right, so now in this next example, the mid-segment is equal to twice, or this outer length is 2 times the mid-segment. So in order to find this, we're going to have to divide 26 by 2. So the mid-segment is 13. And lastly, now this one we don't have to actually do anything. If you remember, the mid-segment is created by the midpoints. So this point E is a midpoint. Well, that means 6 and x have to be the same. If E is right in the middle, those two have to be the same length. So this one's kind of a different one, but x is actually just 6. Okay, now let's move on to an example that's a little tougher. It's going to involve a few more steps, but I think we can handle it. Okay, we are going to use triangle GHJ, where A, B, and C are midpoints. And then let's write this information in here. If AB equals 3x plus 8, so this length is 3x plus 8, and GJ, so GJ is this length here, they tell us that is 2x plus 24. What is AB? So we're going to figure out the length of AB. Well, in order to figure out the length of AB, we need to know what x equals. So first we have to find x. Well, I know that GJ is this outer length. And if I take 2 times the mid-segment, AB, I will get the length of GJ. That's what we were doing in those last examples. So for example, if we knew that AB was 5, we would know that GJ is 10. But we don't know that. So what we have to say is GJ, which is 2x plus 24, is equal to 2 times AB, which is 3x plus 8. All right, so from here, we're just going to solve this using our algebra skills. So first of all, we can distribute that 2. We'll get 2x plus 24 equals 6x plus 16. And let's get the x's all on one side. So what I'm going to do is subtract 2x from both sides. I don't like to work with negatives if I can avoid it. So these will cancel. I end up with 24 equals 4x plus 16. And let's go ahead and subtract that 16 to the other side. Those cancel. We get 8 equals 4x. So lastly, if I divide both sides by 4, I get 2. And this doesn't want to work for me, so let's try this. All right, we'll use this one. 2 is equal to x. Oh, I don't know why I boxed that. So 2 is x, but remember this question is asking for AB. So we need to take x and plug it in for this expression. All right, so that's our last step. AB is equal to 3x, which we now know is 2, so 3 times 2. plus 8. And that would be 6 plus 8, which is 14. So AB is 14 units long. Well, now that we know that, if they did ask us for GJ, we could double this and we could say GJ is 28. So once you know one midsegment, it's easier to find the outer lengths, so whatever lengths they're asking for. Okay, let's go ahead and flip to our last example for today. All right, so we have example 6. Find the coordinates of the endpoints for each midsegment of M and O. Okay, so this is going to involve some algebra. We're not actually going to get numbers for our answers like we did in the previous examples. So what we need to do here is they're saying we're going to find the midsegments of these 3 points here. So in order to do that, we need to figure out, first of all, where these midpoints are. Okay, so let's go ahead and figure out where those are. So first of all, I'm just going to name these. I'm going to call this A, this B, and this C. And to figure out where those midsegments are, we have to find the midpoint. Well, if you remember, there's a formula that helps us find midpoint. So if you have some room above this example, I'm going to move this down, we're going to write down the formula that calculates midpoint for us. All right, so that midpoint formula tells us to take the x values, so we usually say x1 plus x2, and then we divide it by 2, and then we take y1 plus y2 and divide that by 2, and that gives us the midpoint. Okay, so we're going to use that formula with these 3 points. First, let's find point A. Now, point A is the midpoint of O and M. So what we need to do is add the x values together. So you can see the x value of O is 0, and the x value of M is B. So we're going to take 0 plus B and divide it by 2. And then we're going to take the y values, 0 and C, add them together. So we got 0 plus C, and then we divide by 2. Okay, and we can simplify that. 0 plus B is just B over 2. 0 plus C is C over 2. So this would be the midpoint of O and M. Okay, so we're going to go ahead and do that for the second 2 points. So let's do point B next. I'm going to erase these highlighters so we can see what points we're looking at. All right, so for point B, we add the x-coordinate. So the x-coordinate is M. Of M is B, and of N is A. So we're going to take B plus A and divide it by 2. And then we're going to do the same thing with the y, C plus 0. So we have C plus 0, so 0, and divide by 2. And then we simplify. So this is going to equal B plus A over 2. We can't add those together because they're not like terms. And then C plus 0 is just C over 2. And then lastly, we have point C. Okay, so let's look at point C. The x-coordinates of the ends of C are 0 and A. So we have 0 plus A divided by 2. And then we do the same thing with our y's, 0 plus 0. So we have 0 plus 0. Those are zeros again. And divide by 2. And then we can simplify that. So 0 plus A is just A divided by 2. 0 plus 0 is 0. And if you divide 0 by 2, you still have 0. All right, so these would be the coordinates. This is the coordinate of A. This is the coordinate of B. And this is the coordinate of C. All right, well, thank you guys for tuning in. Let me know if you have any questions. Feel free to comment below, and we'll see you guys next time.